Developers use the Shotgun Python API to create, find, update, and delete entities in Shotgun, to upload and download files, and to make changes to a Shotgun site's database schema. Using the API to automate repetitive tasks can save enormous amounts of human labor, but there are also ways to abuse the API, to create scripts that take minutes, hours, or even days to run, clogging up bandwidth at your studio, creating an unwieldy Postgres database, and decreasing performance on your Shotgun site. In this video, we're going to review best practices for the Shotgun Python API, common mistakes developers make, and additional strategies that'll help you get the most out of the API. I'm going to create a simple Python script with a CLI and promote some general Python best practices. CLI stands for Command Line Interface. First, create a file with a python.py extension. I'll call this one bestpractices.py. Open up execute permissions for your user. Next, specify a version of Python to use when the script is executed. It's generally good practice these days to use the version of Python in the current environment, unless you have specific requirements. Next, I'll leave a little note here at the top to remind myself what the script does, why I wrote it, and also to help other people grok the situation if they happen across it. Next, I'll grab argparse and some related modules and set up a little boilerplate CLI and a logger that spits files into an adjacent logs directory. And I'll use the datetime module to time how long our run function takes to complete. Cool, done. Let's see what happens when we execute the script. Okay, it's telling us to add a help flag. Now it gives me a little description, and after I read it, I'll decide to use the run flag. Great, we've got a little idiot-proof timer script that we can add arguments to as needed. Before we can make mistakes with the API, we need to connect to a Shotgun site with it, so I'll do that now. First I need the API, so I'll make a little virtual environment and install the API into it. Great. Okay, let's create 100 shots and time how long it takes. Wow, that took a long time. So what did I do wrong? What can I do to speed this up? Let's add a few diagnostic debug statements. Cool. So it should be obvious from the output here that we're doing two things over and over unnecessarily. First, connecting to Shotgun. We only need one connection. So I'll move that code out of the loop. What else? Right, we don't need to grab the project over and over either. Let's just do that once. So I'll move that code out of the loop too. Let's see what kind of performance improvements we get. Wow, that was a lot faster. But let's see if we can do even better. Each time you call an API method, data is passed between your script and Shotgun's Postgres database, and that slows down your scripts for two reasons. One, your network connection is used, and two, queries have to make a round trip from the Shotgun application server to the Postgres database and back. The moral of the story is, less Shotgun API calls are better. Which means that anytime you're in a loop, it's especially important to ask yourself, is there a way I can do the same thing with less API calls? In this case here, instead of running a create API command for each shot, we can gather up the create commands in a list and then send all those commands to Shotgun at one time with a batch command. I'll write that up now and we can time it. Wow, right? So, to summarize, we can dramatically speed things up by avoiding redundant API calls, like authenticating and connecting to Shotgun over and over, or querying the same project over and over. We can also get a huge boost in speed if we gather up our request commands in a list and then send them to Shotgun at one time with a batch command. Here are those numbers again. In other videos, I've promoted the use of the find1 command over the find command. I've said find1 is faster when searching for a single entity in Shotgun. Now I'm going to put my money where my mouth is and run a speed test. First, I'll make a new function to run this test. I'll also go ahead and give the run function a better name. After I do that, I have an opportunity to optimize my use of the API. Can you guess what it is? Right, I can share the Shotgun connection between functions. So I'll tear that out up here, and while I'm at it, I'll also share the project, and get its ID from a required script argument. Excuse me a moment while I refactor this. And real quick, I'm going to add a delete shots function to our script, in case I run create shots multiple times and I want to clean up. All set. Okay, so let's search for some shots. I'll use a find command and grab the first element in the array. The assumption here is that the shot name is unique, and log the shot name. Let's see how long it takes. Cool. Next, I'll test the find1 command to see if it's any faster. A little bit. So using find1 might make a noticeable difference on a long-running script. But to be honest, I don't really care about the minor speedup. I typically use find1 because 1, it signals to other programmers that I expect only one result, and 2, I don't have to grab my entity from the first element of an array. That's a bit ugly looking. Anything else here that I can optimize? Well, this contains bit. That's doing a text match in the database, which can be time consuming. So let's change this to an is statement and pass in the full name of the shot. Let's see if that's any faster. A little bit. You can imagine that this will slow things down more if the shot names were way longer, or a lot more if you filtered on a description field or an entire note reply, since the entire string is matched. It's a similar situation for the starts with and ends with filters. They're faster than contains, but meh, they're still not a great choice if you can hit your target another way. Here's another one. If you add extra field values to your find query that aren't necessary, that can slow things down too. Let's time it. See, it's a little bit slower with all those extra filters. And finally, what's the elephant in the room here? Right, let's use the batch command. Woohoo! Just kidding. The batch command only works with create, update, and delete API calls. Bummer, right? But wait a minute, we can use the find command like a batch command. Check it out. Let's see how fast that is. Oh snap. So let's put those numbers up. Again, the moral of the story is, if you can avoid running API calls inside loops, your scripts will go faster. Look for creative ways to use filters with the API if you find yourself writing an API call inside a loop. Let's take a look at the event log entries on our site, specifically the ones generated from the batch API calls in our best practices script. Notice anything funny? Right, an event log entry was generated for every single shot CRUD request in our batch API call. So we're generating a ton of event log entity records, even though we're being clever in our script. And if our script ran all the time, the event log database table might get unwieldy. Although Shotgun does a great job optimizing the event log entry database table, we can also use some common sense on our end to improve the situation. On the scripts page, you may have noticed the generate events Boolean field. Let's turn that off for our best practices Python script. Now our script won't generate any events. That was easy. Problem solved, right? Well, now we have another problem. Now there are no records of our script doing anything in Shotgun. What if it flies off the rails and deletes a bunch of stuff it shouldn't have? We'd have a hard time tracking an issue like that back to our script without any evidence in the event logs. So what do? Well, we can create a custom event log entry with the API in our script, but we'll be conservative and only create one log entry for each batch command. I'll toss our message into the description field, link up our project since we have that info, make up some event type. This can be any string, but try to be consistent across your scripts in case you want to filter for it. And then I'll pass in some metadata about the shots I created, in case someone wants to rewind my script's changes later. Done. Let's run it and see what it looks like in Shotgun. Pretty cool, right? You can imagine how useful this strategy is with scripts that run via cron tab, via the event daemon, or webhooks. And of course, you don't have to turn off generate events to create custom log entries, so there's all sorts of creative ways to leverage them. I'm going to go ahead and add an event log entry for our delete shots function too. All set. Let's keep going on the topic of event log entries. Early on in my time at Shotgun, I was asked to create a burn-down graph that tracked tasks completed over time. I believed my only option was to query the event log table. Here's what the code looked like. Let's add that function to the parser and run it. Not so bad, right? Okay, but what if I remove some of these filters? Yeah, getting a little sluggish. That's because the event log table is typically the biggest data hog on a shotgun site. You've already seen how many event log entries were created when we run batch commands. All those event log entries have to be gathered up by the application server and then transferred over the network to your script. And the longer you use your shotgun site, the more event log entries could be returned. They're rarely deleted. Also, this is a test site that no one uses except me, and I hardly ever use it, and it's still slow. A legit production site with tens or hundreds of users and dozens of projects produces heaps and heaps of event log entries. The moral of the story is, only query event log entries as a last resort, and if you do have to query them, try to be smart with your filters to prevent a ton of data from clogging the wire. So event log entries with the API equals badness. But what if I still need to build a report or graph from historical data, or sleuth out the state of a field on a certain date? Are there alternative ways to solve those problems? Yes. First, take a look at the Shotgun event daemon. You'll find it in the Shotgun software GitHub repo titled Shotgun Events. The daemon watches the Shotgun event log and can take action when specific events occur. That way scripts run proactively instead of retroactively, and the event log entry queue strategy is optimized. I also encourage you to check out a repo called sgcron datapoint. The script in this repo can be configured to write a data point to a custom entity every night via a cron tab or other process scheduler. At that point, it's a simple matter to hit that custom data point entity to generate historical data graphs or reports. Finally, Shotgun is always working on better solutions, so it's likely that in the near future, historical data tracking features will materialize, as well as webhooks, which could both solve issues you may otherwise attempt to solve with event log queries. If you're writing a script that requires specific fields to exist on specific entity types, then you can, of course, use the API to check for those fields and add them as needed. Super convenient. I'll write a little bit of code here that updates a text field called sgmonkey on any entity it comes across. Since we know the monkey field won't exist initially, this code will fail. Let's verify that. There you go. We get a Shotgun API 3 fault exception. Okay, cool. Well, let's add an exception handler to cover this case. And add some code up here to create the field if it doesn't exist. What's wrong with this? It seems a bit overzealous to run this schema field read function every time the script is run, right? So let's break the schema stuff out into its own function. I'll call it setup schema and ask the user to run it if we hit an error. Cool, much better, less magical, more engineering. And let's see it in action. I'll try to update a monkey field on a sequence entity. There's our nice little message. Okay, Mr. Script, I'll run you with the setup flag, just like you're asking. Sweet, and now let's see if our update command works. Great. So the moral of the story here is, while it is a good idea to automate schema setup, those API checks and updates only need to be done once, or at least infrequently. So it's a good idea to think about separating your schema checks and modifications out into separate setup functions. While we're talking about schema calls, I'm going to call out one of my pet peeve bad behaviors, and I'm going to do that at the risk of introducing you to a bad habit. As we already know, when you query an entity in Shotgun, a minimal amount of information is returned, the entity's type and ID. If you want more information, for example what the entity's name is, you've got to look up the internal field code and specify that explicitly in the field command's third argument. Now, you clever people may have already found a shortcut, which is this. You can simply pass in the keys from a schema field read call, and voila, you get all the entity's fields and field values in the payload. Great, right? No, super bad. Let's look at the timestamp here. And now let's use the original method of specifying just the information we need. Cool, so that took this long. And that's a big difference. Let's put up the numbers. Wow. But it makes sense, right? You're pulling a ton more data over the wire with the keys strategy, and our FACO shot field values are none for the most part, which means the call would be even slower with real production shots. I hope you're glad to have the schema field read keys trick up your sleeve, maybe for messing around in the terminal, but it will benefit you in the long run to learn the good habit of explicitly declaring your fields and not taking this shortcut. While we're on the topic of shortcuts, let's take a quick look at some of the less often used methods. My favorite unused method is summarize. I'll add a quick shortcuts function here and then count the number of shots in my project. Super fast. Next, let's get all replies to a specific note in chronological order, which could be a pain with the standard CRUD calls. Cool, easy. Now let's add thumbnails for 100 shots by sharing a thumbnail from a single shot. Nice, so fast. That would be super useful used in conjunction with some filtering. For example, I could share a truck thumbnail with any asset that had truck in the name. I'll stop there, but I urge you to look at the followers and activity stream read methods, and also the new filters presets that were introduced in Shotgun 7.0, like the latest preset. That's a super useful one. Before we conclude, I'd like to highlight a relevant support doc. It covers some of the same topics in this video, but in a little more detail. There's some great discussion about filtering. I've also posted the script we created in this video here. And finally, I'd like to mention that although sharing a Shotgun connection object is a good strategy, it's not currently thread safe as of February 2018. So don't share a connection object across threads. Check out these lines in GitHub to see if that's changed.